Hi, I would like to explain the coefficient of determination in this video. So in LM function output, you can see the R square value and adjusted R square value. In the previous example, we fit the price on square footage, and you can see the multiple R squared value here and adjusted R square value here. So first one is written as R square, second one adjusted R square. So these are similar values. Adjusted R square is slightly smaller. What does that mean? So at first, the R square value is defined by 1 minus SS error over SS total. So sum of squared error over sum of squared error total. And SS error is defined as the sum of residual square. So this is epsilon I hat square. And SS total is defined by just the variability of data. So yi minus y bar square. So it evaluates how much variability the y has, response variable has. So R square is 1 minus SS error over SS total. So this ratio SS over SS total, so this is the ratio that we cannot explain the variability by predictor X. So that means the R square is basically the proportion of variability in Y explained by predictor X. Okay, so R square means if R square is 0.4551, so that means the 45.51% of variation in Y is explained by the predictor. And adjusted R square, we have similar formula, but we have some adjustment term, n-2 and n-1. So this is the definition and the meaning of R square. And why adjusted R square is defined when these definitions are so similar. So that is actually the meaningful when we extend this linear model. So now we only have one predictor, but think about the case that Y is explained by multiple predictors, such as, okay, so if Y is Y is weight gain, maybe we want to explain Y by maybe calorie intake and also maybe amount of exercise and temperature and so on. So in such a case, so in general, that we have P predictors x1 to xp, then adjusted R square is defined by this quantity. So we divide SS error by smaller number. So this is basically done because if we have more predictors, then naturally that we can explain more for finite data. For example, if we have 100 observations and if we have 99 predictors plus intercept, then we can explain everything unless predictors are linearly dependent. So in such a case, the R square isn't really a good measure for overall fit. So we make the denominator this n minus p minus 1 smaller than when p is larger, so that we can calculate a kind of appropriate measure to see how much x can. And mathematically speaking, this adjusted R square has good property that expectation of adjusted R square is equal to 0 if all predictors are useless. So that means beta 1, beta 2 up to beta p is equal to 0, then adjusted R square is around 0. So R square is always between 0 and 1 because this is proportion that the predictor explains Y. But the adjusted R square is sometimes negative. It never exceeds 1, but sometimes the small negative value, such as negative, the 0.02. Yep. So this is the definition and explanation of the R square. Oh, and the R square is named R square because actually the R corresponds to the correlation between X and Y.